So far we talked about two data types. We talked about integers and we talked about floats. We actually ended up talking about a few more data types because we looked at that none type because we got off track a little bit, which was great. So another useful data type is a string, and we just looked at that earlier. So when we did this type, and we put some single quotations here, and I'm just going to say thing, we got back this other class that we were looking at of str, which stands for string. Now, we have basically anything that we can put in the string when we're typing characters in. There might be some quirks that we have to make sure we're doing it right, but we can basically put anything inside of here. So I could say my fav num is 10, which is 10. So it kind of, sorry about the little overriding here, but just assume it's one long line. So we still have this as a type of string. So I put 10 in here, and it's still, it's fine. It didn't get mad at me. So let's actually do this again. Let's do type of 10. So what's going on here? This is it looks like a number, but we put the quotes around it, so it's actually string. That's, whoever said that was right. And so what we're doing here is essentially we can put numbers inside of the string. It's just going to be a different data type when we do that. So instead of being able to see just type of 10 being an int, or maybe we want to do type of 10.0, which is a float, we could actually have either of those inside of these single quotes or double quotes and have that be the string type. So you can see how type can be really useful when we're dealing with stuff and we're not sure what it is. So let's go ahead and actually try out some types. So everybody go ahead and try out either some, if you see on the right side of the screen here, go ahead and try out some of those different types at the top of the screen. Try with double quotes, try with single quotes, try with numbers with decimals at the end. Try all of those right now, and I'm sure at least one of you will come up with something weird enough that they'll have a question for me. So please go ahead and give it a shot, and I'll prep the next little part here. So in addition to being able to assign variables to those numbers and the floats that we looked at earlier, we can also assign variables to strings. So name here equal Fernando. So now name, which is a variable we just defined, is equal to the string of Fernando. And it's the same way we deal with those number variables, or if we had a float or an integer, if we did type, oh, excuse me, this isn't right. If we did type of name, and we put name into that function, it's going to tell me name is a string. Well, if we did that before with something else, so let's say my name, it doesn't understand because my name isn't a variable, it's just us typing some things in there. Now the reason that this did work right up here is because the name that we had there was assigned to a string. So that name variable was actually, when we're evaluating everything, just Fernando, the string. So that's what they'll call me from now on. So we can do that with strings as well. So in addition to being able to put those into variables, we can also do some fun stuff with strings that we can do similar. We did similar things to numbers too, but let's go ahead and try and use the plus symbol to do something to strings. So I'm going to go ahead and say hello, and I'm going to say everyone. So I can add these together. Now, it's not technically addition because we don't have numbers that we are merging together. What we're doing here is called concatenation. So concatenation is going to essentially smash the things together. The first thing we give it and the second thing we get it is just going to go bloop, and put them together as the same thing. Now we can do that with the plus symbol, but let's say we tried to do, like, now that we have hello everyone, let's try minus everyone. This doesn't work. So that's because the minus symbol isn't supported as an operation that we can do to strings. We can do plus because we can always just add them together. But when we want to minus things, it doesn't really always work because strings won't always have a kind of clean way to do a minus operation. It just doesn't end up making sense as much for strings as it does for numbers. So let's go ahead and actually try playing around with some of those other operations. So go ahead and create your own string. You can put it in a variable if you want. You can just type it out as a string with some quotes, and then try those arithmetic operations that we talked about earlier. So the pluses, the multiplications, the subtractions, the divisions, and see what happens. Question? Yep, so hello. So you did, oh, sorry, so you did, is this what you did, something like that? Oh, you didn't do the plus. So like this? Okay, so we hit enter here. That's a good question. So what's happening here is essentially, I think this is implicit concatenation, basically. So when Python sees two strings right next to each other, sometimes it doesn't necessarily need the plus symbol to add them together. I'd say the plus is probably best practice for you to kind of know what's happening. But technically, once Python sees these two strings right next to each other, it's like, oh, let's just put these together. Let's just put them back. It's not always going to do that in different situations. Maybe like we're doing, I don't know, if we had some other operations that we were doing the same thing. I'm trying to think of a good example. There we go. That's a great suggestion. So, or hello, yep, hello, too. So it's not always going to automatically try and do the plus there. Question?
Type mismatch.
Yes. So there's when it sees both of those as strings right next to each other that are defined with the quotations, it's going to do that. But see, we have name here, where name is a string. Technically, it's Fernando. But even when we do name and right next to it we do hello, it doesn't work. So generally, we would use the plus to add it together, but when we're putting a bunch of quotes around stuff and they're right next to each other, Python's going to go, okay, I'll give you this one. It's fine. Any other questions about that? So I told you to do arithmetic stuff. Go ahead. That?
Yeah, that.
Okay, so that's a float. So what actually is happening here, 4 divided by 2, is equal to that 2.0. So what ends up happening in here is we evaluate 4, so this is a little off track, but that's okay. So what happens is it's saying, okay, let's do 4 divided by 2. We'll get 2.0, so okay, let's just go ahead and put 2.0 in there. Does that make sense? And then we hit enter, and what we're really doing is saying, okay, finish up what you have in there first, and then I'll do the checking of the type on that. Does that make sense?
I was wondering if that's happening out of these operations. I say 4
That's
times 2.
4 times 2. Okay, so that's a good question. So the reason that it's changing here is because when we're dividing, we're actually getting a different type. So when we're doing 4 divided by 2 in Python 3, it's going to give us a float in this case. So it's saying 4 divided by 2. Okay, it's 2.0 because the dividing is going to give us the 0.0 at the end. Now, if we were doing say 4 times 4. See how we get 16, we don't get 16.0. So when we're doing type of 4 times 4, we're still going to get int because what's in here in 4 times 4 is 16. So if we did type 16, we're still getting an int.
So the operation is going to be calculated first.
Yes, exactly. Yep.
Between the brackets is going to be calculated first, and then the whole statement is going to be executed.
Yep.
You mentioned something about Python 3 versus earlier versions. So is this one of the differences between the multiplying, let's say, dividing 4 by 2? Is it the same thing in previous versions of Python? Is it going to be float or?
So this is Python 2. Let's make this a little bigger. We won't do. Oh my gosh, that's way too big. That's bigger than I want. Okay, well we'll start there and I'll just close this out. So 4 divided. This is Python 2. 4 divided by 2. This is 2. It's not 2.0 anymore. So this is because it's Python 2. So this is one of those quirky differences. Now I don't want to go too much into that because I don't want to confuse you about the differences because I just want you to learn Python 3 right now because it's better it's more modern and it's not going to be Python 2 is not going to be supported past 2020. So it could start being kind of a bad thing to use. Question? Okay, so I told you just a few minutes ago to try using some operations on the strings. Who did that and got a result that they were kind of confused by it, or it looked weird? I'm sure someone did. Yes. What did you do?
Embedded syntax.
Cool, so what did you try and do? Let's type it out.
I just put my car equals.
My car equals to, like this?
Without the, what's the significance of the underscore?
So let's go, it's just to separate words in a variable. I don't have to have it. I can do my car my car equals 2. So that should work. Did it break?
Yeah.
I'll have one of the TAs look at that because I don't know what happened there. That's a good question. Whatever it is a good question. So my guess is that you define a string first and then maybe did something, but sorry, go ahead. Yes. Let me, sorry, let me Yes, yeah, let me go into that. So that was a good question. The question was, when I'm naming variables, I'm using a specific convention to name variables. That is true. I'm using a convention where I'm using all lowercase in this case. And I really got to stop saying stuff like that. I'm using all lowercase, and I'm putting underscores between the words in the variable's name. Now, that is convention. I could define variables like my car and set them equal to, I don't know, Toyota or something. And that would work fine. We can still use variables like my car with a capital C and no underscore. Those will still work fine. It's primarily convention. Different projects will use different conventions. Different programmers might use different conventions. Python, the main convention for Python is to use the underscores between the words, but not everybody does that. So that is a good question. It is completely convention. The only enforced rules are the ones I talked about earlier with the numbers at the beginning don't work. So if I say 20 num equals 100, it's not gonna work. So no, so I could have all words capitalized. So my num, or sorry, let's just go my name equals Fernando. I could do this too with a capital string, and that would work fine. So my name, still a string, still works fine. I could do my name capital and have it be equal to a lowercase string. Doesn't have to be a capital string, and it still returns everything back the same way. Now, the issue becomes if I want to do my name, it's lowercase now, it's not going to work. I have to keep consistent the capitalization that I'm using. Does that answer your question? Cool, great. All right, so getting back to string operations that we were looking at. So who had another weird one? Did anybody try and multiply a string and a number?
No, so.
Did you try?
No, a string and a number. So I space M.
Okay, let's try it.
And then another one is awesome.
So sorry, say that again. I space M. Did you try this?
No,
I'm sorry.
AM, like M.
Oh.
And then another one is here. I am here, right? So
Sure.
Yeah.
I'll just do this.
Are you trying to concatenate?
Oh, gotcha. I am. Okay, I'm going to do caps as a little easier. Plus here. So something like this?
Yeah.
Okay, so that worked. That's great.
Yeah.
So one quirk that we might see there is that there's no space after that, and that's because Python doesn't see space. There's no space at the end of the first part, and there's no space at the beginning of the second part. So it's just going to smash those right together. If we wanted a space in this sentence, we could either add one at the beginning of the second part, which would do I am here, or we could add one at the ending of the first part, and that would also throw in a space. So that's a good suggestion, good clarification there. And who tried multiplication? Somebody tried multiplication. Who's the cool person? Somebody try multiplication right now. Or just tell me to try and multiply some string. So somebody give me a string that they were using.
I did the I am here.
Okay, I am here. Okay, let's do
I did
I am here.
Well, I did I am in quotes plus then here multiplied 4.
Okay, let's try that. I am here. Did you do it like this?
Yes.
Okay, so this is a great example. This will be perfect. So I am here. Whoa, what happened? So let's think about the math operations first. So let's walk through this step by step. So the first part of what actually gets evaluated on this line right here is the multiplication. So multiplication happens first. So we actually do here the string times 4. So when we use multiplication on a string, let's just go ahead and replicate this down below. So we'll do here times 4. So that's the first part of what happens on that line right above. So we get here. So it gets 4 here's with no spaces.
Take a note on this.
Oh yeah.
I want to add one more on this because I know some of you here have never programmed in the past. So in general, programming languages or computer, the way it reads what you type for it is always left to right, top to bottom. But when there are operations, it's gonna execute. It's not gonna start from the left. It's gonna execute the operations with a higher priority, like multiplication and divisions are always first, and then addition and subtraction are next in priority. So if I have an addition and multiplication in the same line, but if you have brackets, whatever in the brackets will supersede all of that.
Yeah, so the parentheses that you're using, the curved brackets here, will supersede everything. So if I do I am here like this, we're actually going to get the order of operations changes up a little bit differently. So parentheses will mean, okay, do this first. Python, do this stuff first, and then do the stuff that's next with the other order of operations. So let's actually go back to that example we were doing up above. So let me get rid of this a little. Okay, so I am here. So this is the weird thing we were getting, right? So it was I am plus here times 4, and then it gave us that. So the reason for this is because the first thing we're doing is we're doing here times 4, which we can see right here. So this becomes here, 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 here. And basically what this means is if you can kind of think it's similar to adding it for concatenating it 4 times. So this is essentially is equivalent to here plus here plus here, and then one more time plus here. So it ran over a little bit the line, but that's essentially the same thing. So we're redoing the concatenation operation that many times to the same string. So it's getting added to itself 4 times. Question? It is this. It should be the same thing. Yes. So that's a. So on. Yes. Here, and you use single quotes.
What is the question?
Let's look. I'm about to find out. We'll see what happens here. So it should do the same thing, right? Good. Okay. No worries. No worries. Gotcha. Yes, that makes sense. So yeah, the reason for that is because depending on what we broke the string out here. So if we had this, if we had I am here as one string, what would happen is Python would see, okay, let's take this one string and let's add that to itself 4 times. What we did up at the very top is we started with the first operation, which was here, the string times 4. So here the string times 4 gave us here, 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 here. And then we did the concatenation. So let's go back up one more time. I'm going to clear this real quick. So we have this one, and then we did this one. So now we know what the latter half of that first line does. So we have here times 4 gives us this. And then basically what we're doing is we're adding the I am at the beginning. And so if we did that, for example, let's just go ahead and rerun that line up there again. Then we're going to get the I am at the very beginning. And it's going to concatenate to that string that we just saw right there, and then it's going to be here, 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 here. Is that confusing still, or does it make sense now that we've looked at it? Question, sorry.
Yeah, if I will do, you see, not multiply 4, but multiply it 2 times. Yeah, one more time.
Like this?
No.
Sorry.
2 stars.
Oh. Gotcha. I see what you're saying. So like this.
Yeah, 16 times.
So that doesn't work because this. So the star star is a power operation. So remember how I was saying earlier that 2. This is the math syntax. Is basically in Python. This is Python. This is math. Then 2. Oh shoot! Can't do stars very well. Star, star, 4. So these are the same thing in terms of how we would look at them. This is a horrible star, but this is how we would tell Python to do that same operation over here. And when we're working with strings, Python doesn't understand what we mean by taking it to the power, because the thing we're dealing with initially is not a number. So it doesn't assume that it wants to be multiplied by 16 or something, because that would assume that this would be a 2, I think. Yeah. So does that kind of help? So basically, if we were looking at math, like we wouldn't really know what to do with high raised to the power of 4, right? So that's why Python doesn't understand. Say it again.
It's only for numbers.
Yes, exactly. It's only for numbers. So this operation we're only using on numbers. Correct. That's why it doesn't work. Okay. Question. Yeah.
Yeah. So for every word that you type has to have a string in the beginning. If it's not written.
Yes, it has to have a letter in the beginning. Sorry, if we're defining variables.
Sure.
So I think, so technically no, we could have an underscore at the beginning. If we're talking about variables, so let's say name again equals Fernando maybe. Then that could work. We could have underscore name. But we can't have a number at the front. Can't be 10 underscore name or 10 name equals Fernando.
So what would you call the first word? Is it command or is it?
So the first, you mean the underscore name? Sorry, the first word. So like what is the...
Right after the 3 arrows.
Right after the 3 arrows, gotcha. So this thing right here, that's a variable. So that's where we are storing something in that. In this case, this isn't a variable because we couldn't make it a variable because it starts with the 10. It starts with a 1. So that doesn't work. So back there, the underscore name is also a variable. Basically, whenever we're saying something on the left, one single equals sign, something on the right, that means that we're assigning the value on the right to that variable that we are creating.
So what I did was
yeah.
I put MO in the beginning.
Okay.
Plus another MO.
Yep.
Times 2.
Did you use quotes?
I did not.
Okay, so what's happening? Did you define MO as anything before? Okay, so what's happening here is Python doesn't know what MO is.
Okay.
It does. This would be, it's not a string because it doesn't have any quotes around it. And it's also, it's not a variable because we didn't say MO equals
So you have to
MO.
define the variable before we use
If yes, you do. You have to define a variable before you can use it. We can't just assume that Python will know this is a variable. It sees that, it says, okay, did you define this? Oh, you didn't define it? Well, we don't know what to do with it. Yeah, cool. All right, cool. So that gets us through a lot of weird things we've tried with string concatenation. So let's take a look at some errors that we might see. So when we tried to do something like, I'm sure somebody experienced this, they tried to do hello plus maybe 10 or something like that. Well, this error is not very helpful because it's, there we go. Let's try that. You can see a little bit more of it now. Okay, so what Python is telling us here is we have an error. It's giving us this information. It wants to be helpful. It wants to tell us what we did wrong and try and give us information on how to improve it. So what it's actually saying here is, okay, we have this something called a traceback, and that's telling us, okay, we're going to go look back at what we wrote and try and figure out where it was that Python saw something it didn't like. So it goes ahead and it tells us, okay, in this file, depending on if we're using a particular file, this thing called standardin might be called an actual file name. In this case, what we're typing into Python is just called standardin. On line 1, which is this line we just typed in, because Python, every time we're running a new command, it's just thinking that's line 1. We're typing a multi-line command, it'll tell us, okay, that's line 2 or 3 or 4. But for this one-line command, right here, this is the first line, in module. So module in this case is just basically what we're typing into the Python command prompt right now. We don't have to worry about module or about standardin or anything. It's going to say, okay, here's the error, type error. So you had something wrong with the types that we were trying to interact with when we were doing something here. It says it can't convert an int type, so it puts the int in the quotes there to let us know that is the integer type we're interacting with, to a int object to a string implicitly. So when we were talking about, when we were putting those strings right next to each other and just hitting enter, it was kind of implicitly saying, okay, yeah, sure, those look like each strings, we can just add those together immediately. It's kind of implicitly doing that. But when we're saying, okay, hello plus 10, Python goes, I don't know. I don't think we can do that. We have a string on the left here and a number on the right, and I don't know what you want me to do with that. If the 10 was a string, we wouldn't have this issue. So we could say, okay, let's go ahead and use 10. So we wouldn't have that issue because we're giving it two strings to add together, to concatenate together. However, when we're giving it an integer, it's not really sure that we know what we're doing and that we want to do that. So it's kind of just breaking to prevent us from potentially doing something that we didn't want to do. Does that make sense?
Hello?
What it's trying to help us with.
Hello, hello.
Okay, great.
Fernando.
So let's go ahead and take a look.
Hello into 10 would work.
Hello, sorry, hello into 10?
Hello into a string.
Yes, that would work. Yes, because the issue there is the concatenation would essentially concatenate those two strings. It would bring two strings together. When we're doing multiplication, what it's actually saying is not put the so let's go back and use that exact same example. Let's use this 10. So what we're doing here is we're not saying hello and then 10 and then doing that 10 times or something. We're saying, okay, take hello and then give us 10 hellos all kind of concatenated together. Good question. All right. So let's go ahead and try and fix this issue a different way. So let's say we wanted to actually make sure that we weren't going to get this error that we came up with a little bit earlier. So when we have hello plus 10, and we want to actually be able to concatenate something that is a number, but we don't want to have to worry about it giving us this traceback. How can we change 10 into a string without having to type the quotations around it? Because maybe in our program we might be getting numbers at some point, and we want to switch it over. So what we can do is we can actually use the str function here, and this is going to convert a number into a string. So let's go ahead and do this right now. So what's happened here is that we've turned 10 into a string and then added it together. Okay, so like that type that we were using earlier, the string function is going to get one parameter that we're giving into it. And a parameter, basically, we're just thinking of something that we give to this function. We say, hey, here's this thing in parentheses. I want you to use this and do something with it. And when we have the string function here, we can give it a number. And whenever we give it a number, it's going to give us back a string. So this is how we're going to be able to fix this here and actually concatenate what was a number and what was already a string. So we're going to have the string, and we turn the number into a string, and then we can concatenate with the plus symbol there. Cool. Go ahead and try that with some numbers and some strings. Give that a shot, and also try it with the other examples that you see up here. Try string with the float, and also try string with the already existing string of ice cream, and we'll see what happens. And then I'll type it out in just a sec. Question, yeah. Sure. You want to do it like, sorry, you want like that?
No, I'm just thinking like hollow.
Sure.
Yep.
Yep.
It's much easier to turn plus double quotes than.
Yes, I see what you're saying. So why would we use it? Yeah, well, it seems easier. Why would we use it? Okay, so the reason we have this string function is because sometimes when we're writing programs and we're dealing with numbers, we're not always going to have the actual value we're dealing with. We're not going to write everything out. So I won't have a chance to actually quote things, like change them from what we're dealing with, copy and paste and quote. So I might need this to, in my code, turn things from a number that's getting output into a string without me having to go in and add quotes manually. So this is going to be useful when we're writing things that will actually take one value. Maybe, okay, so let's say my num again, num equals 100. So let's say I wanted to, later on, I use it in something more complicated. So we'll look at this particular syntax later on. Let's just call, this is a definition. We're going to define a function. I'm going to call this add. It's going to take a num1, num2, and then it's going to go ahead and add these numbers together. It's going to say num1 plus num2. So when this looks really weird. We'll talk about it later. So this is a function here. So now I can say add 8, 10. Oops, I didn't do anything with it. Sorry, let me fix that real quick. Return this actually. Ah, shoot, nope. This is what I get for trying to do things on the fly. Okay, so this is a function. We'll talk about functions towards the end, probably. So what I want to do here is I want to actually be able to add things maybe that are strings. So this works when I give it 2 numbers. But let's say it gets some input that is like a string, or this might be the opposite example that I want. It's going to get these sort of errors. So if I want to be able to fix things in the function I'm writing and make sure it's either a string or an int, and I'm getting the right data type for the operations I need, these functions become useful because I can use them to help avoid those issues. Sorry if that's not a perfect answer. We'll look at it a little bit more later. Now, one other thing we can do, actually, and since we're on this topic already, is let's say we actually have something like 10 right here as a string. So we know this, if we get the type of this, that the type of 10 is a string right now. Well, let's say we didn't want that. Let's say we wanted int. So we could turn it back the other way. So we could say, okay, let's use the int function and take it from a string to an int. So these are just going to help us kind of avoid issues of things being the wrong type later on. So we'll look at it more. Good question. Great question. Go ahead.
The string doesn't necessarily have to be, it could be a variable length row. So right now, string will equate to 10. If you do x equals 5, and then you string, I'm going to convert that 5 into text.
Yes, that is a good. That's a good example. So if we have a variable as well, I can't just add quotes around a variable. So if we start with a variable of x up here, so x equals 5. So now x, if we look at the type, x is an int. But let's say we wanted to actually use the variable x inside of adding strings together. So we wanted to have x plus hello. Well, that's not going to work. We can't do that because x currently right now is an integer that is the value that we've assigned to it. But let's say we actually use the str, and we had strx plus, what did we do above? Hello? Hello. So now it works because we've turned it from the data type that it was earlier into the string that we needed it to be. So that's a much simpler example that I should have thought of before. Thank you. All right, so let's take a look at another function. We're starting to use some more of these functions. They're cropping up a little bit more. I'm going to go ahead and clear the screen and we can use this. So if you need to clear your screen on Windows machines, it's Control-L, I believe. On Mac, it might be Command-L or something like that. That'll just get you a fresh start, just so you have it. So let's look at string length. So one thing that we are frequently going to want to do is know how long the strings are that we're dealing with. So in order to do that, we're going to have another handy built-in function that Python gives to us for free, and this is called the length function, or len. So let's say I use len, and I give it a string here called, we're going to call this string, the string is just going to be hello. It's going to return back to me the length of the string. So this is the total number of characters inside of the string. So if I do HELLO, it gives us back 5. Now I can do the exact same thing with an empty string, and it's going to give us back 0 because there's nothing in there. Now I could do the exact same thing where I could do a variable, set this equal to some sort of string as well, and let's say I can use the length function one more time on my name, the variable of my name. Now this is 8, so we'll see if this is a good example of why this is different or not. But Fernando is 8 letters, so F-E-R-N-A-N-D-O. But the variable of my name, my_name, is 7. Sorry, I could have used a more clear explanation there. But what it's giving back to us the length of is the string that the variable is representing, not the variable name itself. So let's make it even more clear. Let's just say n equals Fernando, and length of n is still 8. It's not 1 for the variable name, it's the length of the string. Does that make sense? Great. I love hearing yeses. That's great. I also like hearing no's if you don't think it makes sense. Okay, so we've been kind of avoiding the quotation issue that we've been working with. So we've been using double quotes around our strings. We've been using single quotes around our strings, and until now it's all basically worked and looked the same and been fine. But if we actually want to be able to use Python strings, 5 more minutes, thank you. We're going to need to do a few more things to keep track of when we're using our quotations. So right now we know that we can have hello with single quotes. We can have hello with double quotes, and it still works just as well, but we do have to be careful. So if we have that single quote, we talked about this a little bit earlier. Let's say we have let's have fun. This doesn't work. And we talked about why earlier, because Python reads this line, it sees a single quote, okay, let's start the string, it sees another single quote, it's like, oh, what's in the string, I guess? It sees more letters that aren't inside of quotations, it gets confused, it breaks, it tells us, okay, we have a syntax error, invalid syntax, and it tells us, oh, hey, where that is happening. So this is another useful error that it tells us. It kind of points out exactly where it's breaking with this little caret symbol right here, right after that. So in order to fix this, what we can actually do is we can do a few things. We can either start by using double quotes around strings that have single quotations, single apostrophes in them, and that'll work fine because Python will see, okay, double quote start of a string, cool. As long as we don't see another double quote, we're not going to end the string, so we'll keep going through. Sees the single quote, cool, that still works fine. Sees the double quote at the end, it ends the string, that's one string. Now, another way we can solve this if we don't want to mix up double quotes and single quotes is we can use something called backslashes in here. So let's go ahead and use single quotes for this whole thing. And this backslash is going to do something called escape the character. It's going to escape the character in front of it. So what's happening when we use this backslash is Python is reading this line and it's going, okay, single quote. Let's go ahead and start here at the single quote to define our string. Let's move over through the LET. We're going to get to this backslash. It's going to go, okay, I see a backslash. that means let's ignore the kind of the normal thing I would think of when I see it next. So this next character I'm just going to treat as an actual part of the string in this case, and I'll get to the end of the line and then pass through that first quotation and get to that last single quote at the very end of the line, and this will work fine. Now it's going to not have the backslash in the string that we have here, because the backslash is essentially telling it, okay, treat this next character just like a normal part of the string, just let him in, it's fine. So that's how we can actually ignore weirdness that might happen in there. So check time. Got 4 more minutes, I think. Okay, so like I said, the backslash character is a special character that tells you, in this case, what it's called is to treat the next character literally. Yes.
Since we're already talking about backslash,
yes.
I know there are special characters as well. Maybe
yes.
we can demonstrate like backslash n.
Sure. Yeah. So let's go ahead and do that. So backslash can do a bunch of fun stuff. So not only can it say, hey, treat the next character a little special, and take it literally, it can also do some other cool stuff where we'll have backslash and then a specific character that will do some weird things. So with the quotation mark, it says treat this next character like a normal part of the string. But let's say we want to put in here another backslash, and then we put an n immediately after that. Now, backslash n has a special meaning. It means new line. So when Python sees a backslash, it's always going to go, okay, something weird might happen next. And if it sees an n, it's going to go, okay, well, I'm going to treat this like a new line. So when I hit enter here, oh, no, I didn't do this right. Why did I do this wrong? Trying to think. Let's go try this. No, I think I need to actually do it. Albert, what am I breaking?
Right, but we need to break it.
Oh, yes, that's why. Okay, so that's a good point. So when I'm actually just hitting enter here, it still looks like, so see we have the backslash in what's returned here. It says backslash n. Well, backslash n actually means new line, but we haven't looked at something called printing yet. When we're printing things, it's going to evaluate everything inside the string and then actually give us the contents of that in a way that we might want to read it specifically. So in this, if I were to actually use something called a print function, in Python 3, print is a function. This is another one of the quirks. In Python 2, it's actually not a function, it's called a statement, and we don't have the parentheses, but print has parentheses in Python 3, so the 3 Ps, that's what we'll think about. So what we're doing here is we're going to go through and actually evaluate all this by the print function. It's going to take this backslash. It's going to say, okay, we'll treat this apostrophe just like an apostrophe, not like the ending of a string. We're also going to get to this /n and do something weird with it. So what's happened here is we've actually evaluated the string inside of this line right here, and instead of just having the literal character of n or the literal character of the slash and then a literal character of an end, it's going to say, okay, /n is a new line. So that's what's happening here when we're using backslash n. So print is a function, yes. So it has to use print to see that new line. So if we were writing a string out in our code and we wanted a new line to show up, we would have to use this /n here. So I could have a backslash, I could have let's add 2 /n's. So /n. So what's happening here is that we are actually using both of them, and that's where it's kind of hard to see. I'll use 3, so it's a little more /n. One more time. It's hard to see
after the half, and then
yes, exactly. So yes, so these two right here are new. They're empty new lines. But the reason that there's 3 is because we break, we go to the next one. We break again, we go to the next one. And then because we have 3, we break again and go to the next one. So you do have to, in order to see it as new lines, you have to print it. But in order to, in the actual string value that's returned to us, we just see it as a /n. So I know that's kind of a weird distinction. I'll clarify that after the break.